Assalamu students. Today's topic is going to be about numerical questions of the chapter Force and Equilibrium. Let us start with the first numerical. A person throws a ball straight up with a speed of 12 meter per second. If the bus is moving at 25 meter per second, what is the velocity of the ball to an observer on the ground? Let us assume that this is the bus and a person standing with the ball, and he throws the ball into the air vertically upward with a velocity of 12 meter per second, while the bus was moving with 25 meter per second, like this, and he catches the ball as well. Now, the horizontal velocity is equal to the Vx is equal to 25 meter per second. The vertical velocity is Vy, which is equal to 12 meter per second. The resultant velocity, which is Vr, we have to find out. The direction of the angle by which the projection of the ball was thrown was theta r. We have to also find that. The magnitude of the velocity can be determined by this formula, which is according to head to tail rule. Basically is to find the magnitude, and it is basically derived from Pythagoras theorem. That means V is equal to under root Vx square plus Vy square whole under root. That means putting the values of Vx and Vy, we get 25 square plus 12 square, we get 625 plus 144 whole under root, and from that we'll get V is equal to under root 769. After that, we get the value of the velocity magnitude, which is 27.7, and rounding it off, we'll get 28 meter per second by which the ball was moving in the air. Now, for the direction part, for direction we have theta. Theta is equal to tan inverse Vy over Vx. That means the vertical component on top and horizontal component on the denominator or bottom. Putting in the values, we get 12 divided by 25. Taking tan inverse of these two values, we get tan inverse of 0.48. We get the value 25.64 or 26 degrees. This is the answer of this theta r. Moving on towards question number 3, which says a football leaves a foot of a punter at the angle of 54 degrees. Positive x direction at a speed of 21 meters per second. Determine the horizontal and vertical component of the force. Now, we have to assume something, that let's say that this is a foot or leg of a footballer and this is a football. Now, this is the action which is being processed. He kicks the ball has some direction, which is making angle of 54 with the horizontal, and it leaves the foot of the kicker with a speed of 21 meter per second, like this. Now we have to calculate and resolve the components of this velocity. The direction is given, which is theta, which is 54 degrees. The resultant velocity is 21 meter per second. Let us calculate the horizontal velocity, which is Vx, and the vertical velocity Vy. For this, we will convert the horizontal and vertical components. Basically, the horizontal component is this one, and the vertical component is this one. That means Vy and Vx. Vy, here we go, and Vx, and the angle theta is basically 54 degrees right here. So the simple solution is the formula, the resolution of forces, that Vx is equal to V cos theta. Putting in the values of V, which is 21 meter per second, putting the value of theta, which is 54, we'll get 12.34 or 12 meter per second for the horizontal velocity. Similarly, for the vertical velocity, Vy is equal to V sin theta, which is equal to 21 sin 54, which is equal to 16.98 into 17 meter per second, and that is the vertical velocity. Moving on towards a very important question. 1.84 kilogram school bags in the middle of a clothesline, causing it to sag by an angle of 3.5 degrees. Find the tension in T in the clothesline. Let us assume what is going on in this question right here. First of all, we'll say that this is a clothesline, which is attached between two poles, and a load of 1.84 kilograms, and we have to convert it into force. So we multiply it by the value of G, which is 9.8. So answer will be 18 Newton. So if we apply the force of 18 Newton or the weight of 18 Newton on the wire, it bends. It bends with the angle of 3.50 degrees with the horizontal. Both sides will be the same because they are equally feeling the tension. So these angles, are the same, but this angle is also same. This is angle with the horizontal. This is called alternate angles. These angles are also same. So we can say that these angles are also 3.5 degrees. Removing the above angles, we get angle theta on both sides of the wire as shown, and which is 3.5 degrees. Now we have a situation over here in which we have the angle right now, and we have to calculate the horizontal, this one part, and the vertical components of this tension. So first of all, we have to understand that what do we have to find out? We have to find the tension in the wire T, which is represented by T on both sides of the wire. Calculation: resolve the tension to the rectangular components. We have to find the rectangular components, which is the x-axis and y-axis components, horizontal and vertical. The horizontal part is represented by blue color, whereas the red part is represented by vertical component. So first of all, we are applying the first condition of equilibrium, in which it said that sum of all horizontal forces must be equal to 0. That means all the horizontal forces must cancel each other out. Now, if we only take the horizontal forces, we see that the magnitude of these two forces are the same and the direction is opposite. For this, we represent this by an equation that T cos theta, or 3.50, which is the horizontal component, minus T cos 3.50, which is equal to 0. That means the horizontal components are same but opposite direction. Negative sign shows that this T, this component of T is basically in opposite direction to this component of T. Taking T to the other side, it will be T cos 3.5 is equal to T cos 3.5. That means these two forces are cancelling each other out because they have the same magnitude, but they are in opposite direction. Just like this, they have the same magnitude, but they will cancel each other out. So now about the vertical forces. Now applying the first equation, the first condition of equilibrium, which is the sum of all forces in the vertical direction are also equal to 0. For this, we only take the vertical forces, which is one upward and one downward. The downward force is because of weight, right over here, which is 18 newtons. Now the tension is T sine 3.5 plus T sine 3.1 for this one, T sine 3.5 for this one, and T sine 3.5 for this one, because the angle is opposite to this side. That is why it is vertical component, minus because weight is in opposite direction, the negative sign is still there. Putting the values, we get the T sine theta, because now we can clearly see that they are opposite to each other. Two of them are in the same direction, whereas the third one is in the downward direction. Let us combine these two forces together so that we have one force, which is 2 sine 3.5 degrees. Just like this, bringing them closer like this and then combining them, and we'll get 2 sine 3.5, which is opposite to the weight. Now we have to find the T, taking all the other components to the other side, putting the values of W, and here we have a situation again. There's 2 points if you calculate it very much easily. So this 0 is extra. There's no point over here. So our answer will be W, which is 18, 2 is as written as it is. Sine of 3.5 is 0.061. Putting in the values and multiplying, now we get 18 divided by 0.122. After dividing, we get T is equal to 147.5, or rounding it off to get 148 newtons. Thank you. Next, we have a question that Find the magnitude and direction of a vector representing by a following pair of components. Let's say this is the horizontal component, which is represented by negative 2.3, and this is the vertical component, which is represented by positive 4.1 centimeter. Now in the B part, the horizontal component is 3.9 meters, while the vertical part is minus 1.8 meters. So first of all, again, we have to use the formula of the components of forces as well as magnitude of forces and directional forces. For the magnitude, we had a formula by help of Pythagoras theorem. It was that if we have a force F, then its magnitude can be calculated as under root Fx, that means all the forces along the x-axis, and taking square of it, and plus Fy, taking all the forces along the y-axis, square. And for the angle part, we have an angle of theta, so it will be taken as tan inverse like this, and it will be Vy, or we can say in this case Fy, divided by Fx. This. So these are the two formulas by which we can get the values. Putting in the values, we get the answer, and in this case especially, we have to adjust in the quadrant also. The quadrants are 4 quadrants in a graph. The 4 quadrants are, first of all, here x-axis and y-axis are positive. Here in the first quadrant, here the y-axis is positive but the x-axis is negative. Here both x-axis and y-axis are negative. Here the y-axis is negative but the x-axis is positive. So in the fourth quadrant, the x-axis is positive and y-axis is negative, just like this one. So it must be in the fourth quadrant. While in this case, x-axis is negative and y is positive, so it must be in the second quadrant. So we have to solve it, that what is the magnitude of these values. So the magnitude can be calculated by a is equal to under root ax square plus ay square. If putting the values of ax, it will be minus 2.3, the value of ay, which is equal to 4.1 square. Putting the values of square, we will get 5.29, and the value of ay square, it will be 16.81. Putting the values, adding up the values, we will get 22.1. Taking under root, we will get the answer, which is 4.7 centimeter for the first value. For the direction, we have the formula theta is equal to tan inverse ay over ax. Putting the values ay and ax, we'll get 4.1 divided by minus 2.3. We get tan inverse minus 1.78. Calculating it, we'll get minus 16. Now this minus 16 basically is in which quadrant? We have to understand it is in the second quadrant. So 180 is the line, and we are basically adding up that value, and that value theta is 60.67, so it is in the second quadrant. So we are adding up in 180, we get 180 minus 60.67, we get 119 degrees. That means it is going to be in the second quadrant. Moving on towards the magnitude can be calculated by of the A part, we have already done. We are now calculating for B part. The formula is going to be the same. A is equal to under root ax square plus ay square. Putting in the values of ax and ay, we get ax equal to 3.9 whole square plus brackets on minus 1.8 whole square. We get 15.21 plus 3.4, taking whole under root, and we get 18.24 whole under root. We get a value of this a, which is for 4.29 or 4.3 centimeters. So in the first case, it is going to be, we have to write down in meters because both of the values are in meters. So this also has to be written in meters, not centimeters. The answer must also be equal to the meters part. Now for the direction part, the tan inverse ay over ax, putting the values of ay, which is equal to minus 1.8 divided by 3.9, which is equal to tan inverse minus 0.46. Putting the values in the equation, because it is in the fourth quadrant, we are basically separating by 360. the angle which is 24.7. So putting the value of 24.7, the negative sign will multiply by positive sign, it will be negative 360 minus 24.7, it will be 335.2, which is in the fourth quadrant. And this is how we can solve this simple question. The vector having magnitude of 5.5 Newton makes an angle of 10 degrees with x-axis, and a vector of r with a magnitude of 4.3 makes an angle of 80 degrees with the x-axis. What is the magnitude of their dot product and cross product? Now in this case we have to assume that there's a graph, there's x-axis and y-axis, there are two forces or two vectors, I might add. One is a force which is of 5.5 Newton magnitude making an angle of 10 degrees with the horizontal, while the other one is r which is 4.3 meters which is making an angle of 80 degrees. Now what is the angle between these two? We have to subtract basically 80 or 10 from 80 and we get the angle between these two, which is equal to 80 minus 10, which is equal to 70 degrees. That means this is the angle between these two forces or these two vectors. Now solution, the vector f is given, which is already given to us, which is 5.5. The angle of vector f is equal to 10 degrees. The vector r is given by 4.3 meters. The angle of vector r is 80 degrees. So f dot r and f is the dot product, so it is written as fr cos theta, putting in the value of f which is 5.5, putting the value of r which is 4.3, cos 70 because the angle between them is 70. Putting in the value of 70, we get 0.34 multiplied by 4.3 and 5.5, we get 8.0 Newton meter. And for the cross product, we have f cross r, which is equal to fr sine theta, f 5.5, 4.3 sine 70, which will be equal to 22.22 Newton meter. Now for the magnitude part of the dot product and cross product of two vectors, which is question number 6. The two vectors having a dot product having the value of 6 under root 3 and the cross product having a value of 6 respectively. Find the angle between the vectors. Now we have to find the angle of between these two vectors actually. Now here is the condition for us that let A and B, the two given vectors, the magnitude of dot product of two vectors A dot B is equal to 6 under root 3. The magnitude of the cross product of the two vectors A cross B is equal to 6. To find the angle between the two vectors, we have to find angle theta. For that, we have first we take this as the first equation, that A dot B, A cross B is equal to 6 under 3. We make it equation number 1. And similarly, A cross B is equal to AB sine theta, which is equal to 6. Now we are going to find the value of theta. Now how we are going to do that? We have a formula of tan. Tan is equal to sine over cos. So we are using that by dividing equation 2 by equation 1. So we have a situation over here in which AB sine theta divided by AB cos theta is equal to 6 over 6 under root 3. So as you can see, this 6 and this 6 cancel out, and our new equation will be AB sine theta divided by AB cos theta. It will be equal to 1 over under root 3. So this two AB's also cancel out. So we have sine over cos. The sine over cos is equal to tan theta, which is a trigonometric function. 1 over 3 under root 3 is given to us. So theta is equal to tan inverse 1 over 3. The values of theta is going to be 30 degrees. Now this is the way we have calculated the angle between the two cross and dot product. Moving on to question number 7. A uniform rod of 1 meter long with a weight of 6 Newton can be supported in a horizontal position on a sharp edge with a weight of 10 Newton and 15 Newton suspended from its end. What is the position of the point on the balance? First of all, we have to assume what is going on. This is the situation. Now in this case, he's saying that this is the rod and it is being suspended on a sharp edge, and two weights of 10 Newton and 15 Newton, but over here it is 13 and 18 because the weight of the rod, which was 6 Newton, was also included. So 10, because it was uniform, so 3 Newtons were included in this one and 3 Newtons were included in this one. So it was uniformly balanced, and 10 plus 3 is equal to 13 and 15 plus 3 is equal to 18. And this is we have equally divided this basically force on both sides in this way so that we can calculate it much more accurately. So the distance isn't given. The distance isn't given on one side and neither on the other side. So we take the x on one side and the total minus x on the other side. That means the total 1 meter. We subtract the x value, whichever comes from here, we'll put in this value and we get the values, the distance from the center point, which is the position of the balance. Now the solution part, the length is 1 meter, the weight on the left is 10 Newton, which can be converted to 13 Newton. The weight on the right is 15 Newton, which we can be converted into basically 18 Newton. So 15 becomes 18 and 10 becomes 13. So we have to find the unknown distance x. So the clock, according to the second condition of equilibrium, the clockwise torque must be equal to anti-clockwise torque, or T1 must be equal to T2. Or putting the formula of T1 and T2, we get F1 R1 is equal to F2 R2. So we don't have the value of R1, so we're putting in the value of X, and F1 has a value of 13 newtons, whereas F2 has the value of 18 newtons, and R2 we don't know as well, so it will be 1 minus X. Now 13 multiplied by X, it will be 13X, so 18 multiplied by 1 minus X, it will be 18 minus 18X. So this 18X goes to the side, it will add with 13, it will be 31X is equal to 18. So the value of X will be 18 divided by 31, or 0.59 meters, but we have to calculate the distance from the heavier side as well. So it will be 1 minus X is equal to 1 minus 0.59. Putting the values of X in this equation, 59, we get 0.41 meters. This is the distance from here. So this is how we calculated the distance from the heavier side. And moving on to the next question. This is a very important question. 4 meter long uniform ladder with a weight of 120 Newton leans against a wall making 70 degrees above a cemented floor as shown in figure, assuming that the wall is frictionless but the floor is not. Determine the force exerted on the ladder but the floor and the wall. Now in this case the situation is over here, and in this case we have a ladder making an angle of 70 degrees with the wall, and then this is the ground and it is frictionless with the ground. The wall is frictionless, that this part is frictionless, but the ground has a friction. Okay, this part has a friction, and that is why the ladder is standing up. Now we are mentioning a few points. Let's say this point where the ladder and the ground meet is point A, where the point ladder and the wall meet is point B. The center point of the ladder is point C, and the point end at the corner of the ground and the wall is point D. And let's call this point underneath the point C E, which we will basically do later on. The weight of the ladder is basically 120 Newton, which is given in the data, 120 Newton. So an angle which it makes is 70 degrees, which we already know that. Now the weight is shown by an arrow which is acting in downward direction, because everything is moving down towards the earth, because earth basically pulls it towards its center. The length of the ladder is basically 4 meters. So here we go, the length is 4 meters. So the distance between AC, the midpoint of the ladder, to the BC is going to be the same. We have to divide it into equal parts. So 4 divided by 2, it is equal to 2 meters. So L by 2, L by 2, half half. So the reaction of the wall is FR, which is over here. We have to see the reaction, how the wall reacts basically. So it is frictionless, but force is being applied on the wall, and the wall applies force back. And because of that, we have a friction reaction force of the wall on the ladder. The reaction of the ground, which is represented by R, which is a Z vector, which is a combination of the normal force of the ladder, which is in opposite direction, and the horizontal force, which is pushing it, or friction force, which is pushing it, the ladder, with the help of the friction on the ground, on the rough surface of the ground. According to the first condition of equilibrium, all the horizontal forces must be equal to 0. So for that case, we only take the horizontal forces, which are FR and FH. So in this case, we can say they both are in opposite direction, which is equal to 0, and FH is equal to FR. Let us take this as equation number 1. Now, if all the vertical forces must be also equal to 0, that means the first condition is again applied over here, but in the vertical condition, so we neglect the horizontal part and move on toward the vertical part. As you can see, they both are opposite to each other, but they are equal in magnitude. So over here, we can say Fn minus W is equal to 0 of Fn is equal to W. Putting the value of W, the value of Fn is equal to 120. Now we have the value of Fn, that is 120, the same as the weight of the lead, because opposite in magnitude is there, but the direction, opposite in direction is there, but the magnitude is going to be the same. Now, according to the second condition of equilibrium, we say that sum of all torques must be equal to 0. In that case, we have a situation that we have to assume the momentum as well as the force, and in that case, the sum of all torque must be equal to 0. That means T1 and T2, that means clockwise and anti-clockwise torque must be equal to each other. So anti-clockwise will be written as blue, whereas the clockwise torque will be written as red. The torque of H and N are 0 because over here there is no momentum. So momentum is 0, so there must be no torque. So torque will be taken as 0. So only two forces or two torques are going to be red. One is the weight of the torque, weight of the ladder. Because of that, there's a torque, and there's a anti-clockwise torque pushed by the wall in this case, which is represented by Fr. So it will be BD into Fr minus AE into W. So BD is the momentum, Fr is the force. In this case, AE is the momentum, and W is the force. For the maximum part of the force to be perpendicular, we are putting AB sine theta into Fr, where AB sine theta is basically BD is representing the AB sine theta, because this is the angle. If we take it as a right angle triangle, then AB and theta is over here, so this will be BD, and BD is AB sine theta. We can write down BD as AB sine theta as well. And similarly, AC cos theta is given because we don't have this horizontal force, because this horizontal force, because we don't have the values of AE. So what do? We take AC, and we have a theta over here, and it is adjacent to this side, so we'll take this point as E, and we'll say that this component is the horizontal component, which is AC cos theta. Putting in the values as we got BD is equal to AB sine theta, and AE is equal to AC cos theta. After putting in the values of theta, we get the clockwise direction, which is represented by red, and anti-clockwise direction, which is represented by blue. We get 4 sine theta, which is AP, and sine theta is 70. FR, we have to find out 2 cos 70, which is the angle, and 2 is the basically distance, which was half from the ladder, and 120 was the weight given to us. Putting the values of 4 sine 70, it will be 0.939 into FR, and the values of on the other side will be 0.34 multiplied by 120 divided by 2. Now we are going to find out the value of FR. After factoring this one, it will be 20.4. Taking 0.93 to the other side, it will be FR is equal to 20.4 divided by 0.939. We get equation 1, that FR is equal to FH, which will be equal to this value, which is equal to 21.72 Newton, which we are calling equation number 3. Now this is the horizontal force, but we have already calculated the vertical force. Now we have the vertical force and the horizontal force. Now we are going to calculate the resultant force by the ground and by the ladder on each other, representing the reaction of the wall. Now by reaction, ground is given by the total force, which is FH and FN. So we have the value FH and FN. We have to find the resultant. R is equal to under root FH square plus FN square. Taking the resultant to the other side so that it is clear. So it will be putting the values of FH, it will be 21.72 whole square plus 120 whole square under root. Putting the values of this square, it will be 471.758 plus 1440 whole under root. So it will be 14400 whole under root. Putting the values, we get under root 14871.758. We get the under root part, it will be R is equal to 121.946. Putting the value of rounding it off, it will be 121.95. Rounding it off, it will be approximately equal to 121 newtons. So this is the question. Moving on to the last question, it says 415 kilogram uniform beam supports, this is nothing, beam supports that the load 220 kilogram has shown. Determine the reaction at the support. We have to determine the reaction. For this part, this is point A and this is point B. The solution is the weight of the beam. We have to calculate that because the mass is given. We have to multiply it by the value of G, which is 9.8, to get it into newtons. And this is the way we can show that the weight is in downward direction of this whole beam. The load is being put on a certain place. Let's call that place point C. And on that we have a weight of 22 kilograms multiplied by 9.8, which to convert into force. This is also acting in downward direction. Now the displacement is given where AB, this point A and this point B, has a total displacement of 8 meters. OA and OB, that means the half distance from here to the half distance from here, it is going to be 8 divided by 2, or 4 meters. So in this way we can say OA and OP is equal to 4 meters, AC is equal to 5.6 meters, let us say this is 5.6 meters, and BC, that means distance from here to here, it's 2.4, sorry. We have to calculate the force at this point as well as this point. First of all, we have to calculate the force at point A and say that what is the force at point A? Is it more or less than this point? So we have to compare it first. The point RB represents reaction force of point B, and RA is the reactionary force on point A. So we have to compare the forces of point A and point B respectively. So for this we have the information now. Now it is a Planck which is balanced condition. So the equilibrium, second condition of equilibrium is taking place, that shows that anti-clockwise torque must be equal to the clockwise torque. And we have to represent anti-clockwise with the blue color and the clockwise with the red color. So the only thing which is in anti-clockwise is the support at B, which is pushing this rod towards the anti-clockwise direction. Otherwise all the other forces, this force doesn't count because we are taking the rotation point at point A. So the moment arm is going to be 0. So that is why I've written A is equal to 0. That means there is no moment arm, so there is no torque over here. Where T is represented by this force and displacement, and T1 is represented by W1 and the displacement from point A. Now after putting the values of this one, what do we get? We get AB if into FB is equal to A naught into W plus AC into W1 into AA into FA, and as we know AA is equal to 0. So that is why I put 0 over here. No writing, no use of writing this question, so I'm putting this as 0. So 8 FB is equal to 4 into 450 into 9.8 plus 5.6 into 220 into 9.8. You can calculate it. It will be 8 FB is equal to 17,640, and it will be equal to plus 12,073.6. The total sum will be 29,713.6, and F8 will go to the side, will be 29,713.6 divided by 8. It will be equal to 3,714.2 Newton. According to the first condition of equilibrium, now we have to find the value of RA as well. Now we have the value of FA or RA, and now we are going to find out the value of the FA part as well, and we'll compare that the force more over here more or over here more. So FA plus FB, that means the forces in upward direction is equal to the forces in downward direction. The upward forces are written in blue, whereas the downward forces are written in red. So this force is upward and this force is upward. So FA and FB are both in upward direction, whereas the W1 and W2 are both in downward direction, right over here. So in this case, we are going to say that if we take FB, because we have calculated FB from equation number 1, it will be W is equal to 415 multiplied by 9.8 plus 220 into 9.8 minus 3,714.2. We'll get a 2,851.8 or 2,850 Newton. So by comparing these two equations, we'll see that force A is less than force B. So as you can see over here, by calculation also, force B, which is 3,000, is greater than 208
800, 2800. So we can say now, by comparison of equation 1 and 2, we can say FA is less than FB. The reason the center of gravity of the whole system is near to, I will say FB rather than FA, because the mass was put near to B than to A. So this is how we can say that the forces are being calculated. Thank you very much, everybody. This is the last question, and this was the last question. Inshallah, we'll meet again. Allah Hafiz.